Having watched my previous build videos and hearing what a dick I sound mumbling away whilst doing stuff, this video hopefully will be better. I'm using a prepared script over still images. This is how far I have got this week, and we are in the middle of January. After a brief trial flight, I realised that the compass needed relocating, but we'll come to that later. Let's look now at it bit by bit in no particular order. The front bumper is a 3D print from a model created by one of the frame's designers. It is all open source and benefits from having many contributors. The antenna is the Team Black Sheep, known as TBS, Crossfire Immortal T with the extra extended cable length. I printed my bumper in PLA material, which is quite rigid, hence the two slots cut in it to enable the antenna to be fitted. Carl has printed his in TPU, which is very flexible and therefore much easier to fit the antenna without cutting it. Moving on to the flight controller with its wiring completed. I have 4 connections with the LEDs and the buzzer. The LEDs are the WS2182 variety and are controlled by the flight controller. Many combinations are available in iNav. I'm just using armed indication and low battery warning. The buzzer is a self-powered type from Wi-Fi. The camera video signal comes into the controller to be mixed with the on-screen display, OSD, and then exits to the video transmitter. Finally, the Crossfire receiver and GPS with compass signals come into the controller. I'll detail later in this thread all the connection details for all the sensors and parts that connect to the flight controller. I use silicon insulated wire. I like to have a very short stripped solder tinned end to reduce possibility of shorts. PVC wire insulation melts and shrinks back, in some cases by a couple of millimeters. Silicon wire doesn't, it's so much better to work with. The battery power cables coming into the flight controller are 14 AWG. They are only 100mm long, so the voltage drop, even at punch-out currents of 60 or 80 amps, is very small. The USB connector is easily accessible from the side, along with the SD memory card for data logging. At the rear we have a Crossfire Nano Diversity receiver. This is mounted in a 3D print to suit the 30.5mm hole spacings for an easy and firm fitment. Below that, using a fiberglass plate from the Maytech controller parts bag, the TBS 2.4 gig video transmitter is clamped. The heatsink is face down to the carbon fibre base, and a thin layer of heatsink compound helps to keep the heat dissipated nicely. On the other side you can see the VTX antenna cable exiting up to the antenna. I'm using a Flytron dipole antenna for the FPV video signal. It's linear polarised and orientated to suit a Yagi receiving antenna on my ground station antenna tracker. The Crossfire receiver is Diversity, hence 2 antennas. You've seen the first at the front, the second is inside this red tube. Both are placed horizontally but at 90 degrees to each other. The ground station has another Yagi antenna, horizontally polarised to suit these 2. The jury is still out on this second antenna in the red tube. I'm still thinking there might be other options. Originally I mounted the GPS in a 3D print at the rear. This seems to be the usual position in this frame, judging by various photos floating around the internet. I'm running iNav and need to use a GPS with a compass, magnetometer to give it its proper name. The compass here is too close to the power and motor cables, and the bulk of the quad affects its ability to read the Earth's magnetic field well through 360 degrees. The upshot was I could not get a good heading lock. I'm of the belief that most people run Betaflight in these quads. They fit a GPS for rescue mode, but Betaflight does not use a compass, so my problem is not theirs. Here you can see I have moved a GPS compass unit, a Beachin 880, up onto a mast 100mm high. Although there are plenty of 3D models on Thingiverse, I wanted this to have my flavour, so I created and printed my own case, lid and mounts. I like lights and sounds on my craft, so I created a custom mount for an 8 LED bar and a self-powered lost model alarm, which doubles up as the usual flight control buzzer. The lost model alarm is the ViFly Finder version 2, and the LED bar is a Maytech part. I'll put links to all parts used in this thread in the next few days. Here's the top deck where the battery sits. With the amount of heavy landings I have, it's best the battery is not underneath. At the front of this deck are the FPV camera mounts. They cater for a small FPV camera and a GoPro style HD camera. In my case it's an Osmo Action. Carl very kindly printed me this mount in TPU material. Intention is to give it some cushioning in the event of yet another heavy landing. And this is how it all fits on the frame. Seems a Cadex Ratal little yellow FPV camera went AWOL for this photo. All ready to go, fitted with 7-inch 3.5 pitch tri-bladed props. The battery shown is a 4S 5200 mAh. It's a bit big and heavy. I'm in the process of building a 4S 2P lithium ion pack with cells that, in 2P configuration, are okay to pull 60 amps. I don't intend this as a sporty punch-out everywhere craft, more of a long-range cruiser, so I'm expecting 60 amps to be fine. Ready to go as soon as this lockdown is relaxed, although I may try a hover test in the back garden tomorrow.